This is SpaceTime, Series 22, Episode 2. Coming up on SpaceTime, is our universe just fuzz on an expanding bubble in an extra dimension? NASA given data access to Israel's upcoming lunar landing mission, and New Zealand's Electron Rocket blasts off on its third orbital mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have devised a new model for the universe which may solve the enigma of dark energy. Dark energy is a mysterious force causing an acceleration in the expansion of the universe out from the Big Bang 13.8 billion years ago. The new model, reported in the journal Physical Review Letters, proposes a structural concept for a universe that rides on an expanding bubble in an additional dimension. Astronomers have known for the past 20 years that the universe is expanding at an ever-accelerating rate. The most popular explanation is that some mysterious force, a sort of negative gravity, permeates throughout the universe, pushing it to expand. Understanding the nature of this dark, or vacuum energy as it's sometimes called, is one of the paramount enigmas of fundamental physics. It's long been hoped that M theory, better known as string theory, may provide the answer. According to string theory, when it's broken down into its simplest form, all matter consists of tiny strings of energy vibrating at different rates depending on whether it's a photon, an electron, a quark, a neutrino, or whatever. But for string theory to work, there also needs to be a lot more than the 3 spatial and 1 temporal dimension currently observed. Some versions have 11, others 12, some even as much as 21 or 23 additional dimensions. But finding evidence for the existence of these dimensions has been impossible. For 15 years there have been models in string theory which have been thought to give rise to dark energy. However, they've all come under increasingly harsh criticism, and more researchers are now asserting that none of the models proposed so far are really workable. This new model by scientists from Uppsala University proposes that our universe is riding on an expanding bubble in an extra dimension. They hypothesize the entire universe is accommodated on the surface of this expanding bubble. The hypothesis suggests that all existing matter in the universe corresponds to the ends of strings which are extending out into this extra dimension. The authors say expanding bubbles of this kind can come into existence within the framework of string theory. And they say it's conceivable that there are other bubbles out there as well, corresponding to other universes within a larger multiverse. While just an idea for now, the Uppsala scientists' model does provide a new and different picture for the creation and future fate of our universe, while it may also pave the way for new methods of testing string theory. You're listening to SpaceTime. I'm Stuart Gary. NASA has signed an agreement with the Israeli Space Agency, giving it access to data gathered by a new Israeli lunar lander expected to touch down on the moon early this year. The 600-kilogram lander, developed by an Israeli non-profit group called Space IL, was recently named Bereshit, Hebrew for Genesis, in a competition. Genesis will be launched aboard a SpaceX Falcon 9 rocket, now slated to fly on February the 13th from the Cape Canaveral Air Force Station in Florida. The mission was supposed to fly back in December, but had been delayed by problems with another one of the SpaceX payloads. Those other payloads include the Indonesian PSN-6 telecommunications satellite, built by Space Systems Loral in Palo Alto, California, and a classified US government geosynchronous satellite. Once launched, all 3 spacecraft will detach from the Falcon 9 in geosynchronous transfer orbit. The Genesis lander will then orbit the Earth in ever-expanding ellipses, raising its orbit each lap until its apogee, that's the most distant point from Earth, allows it to be captured by the Moon's gravity, and it then begins orbiting the Moon instead of the Earth before finally landing. The overall orbital transfer process taking a bit more than 2 months. The lander will touch down in Mare Serenitatis, one of the dark lunar basins visible from Earth between the landing sites for the Apollo 15 and 17 missions. Genesis will collect high-definition images and scientific data from its initial landing site before lifting off again and moving to a second landing site about half a kilometre away. As part of the deal, NASA will contribute a laser retroreflector array to aid with ground tracking, and NASA's Deep Space Network will provide communications support for the mission. In return, the Israeli Space Agency and SpaceIL will share data with NASA from the lunar magnetometer installed aboard the spacecraft. The instrument, which was developed in collaboration with the Weizmann Institute, will measure the magnetic field on and above the landing site. The data will then be made publicly available through NASA's Planetary Data System. NASA's Lunar Reconnaissance Orbiter, which is still up there orbiting around the Moon, will attempt to take scientific measurements of the lander as it touches down on the lunar surface. Together, NASA and SpaceIL scientists will collaborate on analysing the scientific data returned from the mission. If successful, this mission will make Israel only the fourth country on Earth after the former Soviet Union, the United States and China to undertake a soft-controlled landing on the surface of the Moon. I'm Stuart Gary. You're listening to SpaceTime. A New Zealand Electron Rocket is blasted into orbit on its first dedicated mission for NASA. The Rocket Lab's Electron blasted into low Earth orbit from its Mahia Peninsula Launch Complex on the far eastern edge of New Zealand's North Island.
Mission Control is given the go for flight. Electron is fueled and ready at Launch Complex 1 with Electron go, Range go, and the Weather go. We've also informally pulled the sheep and their go as well.
We're reading engines. 10, 9, 8, 7, 6, 5, 4, 3, 2.
Confirmed. IRB tracking downrange.
We've had successful liftoff of Rocket Lab's Alana 19 mission. This one's for Pickering.
Approaching maximum dynamic pressure.
The next major milestone we're coming up to is Max Q, or maximum aerodynamic pressure. This is where the forces on the vehicle are at their greatest during launch. Let's stand by for the call.
Max dynamic pressure.
Stage 1 propulsion is nominal. Open power pack CO2 bottles.
Coming up next are a series of events that take place in quick succession. These are MECO, or main engine cutoff, followed by Stage 1 separation, Stage 2 engine ignition, and then fairing jettison.
Entering burnout protect mode.
Stage 1 main engine cutoff.
Staging.
And Stage 2 propulsion is nominal.
Stage 2 is stable.
Fairing deploy.
And that completes MECO, Stage 1 separation, second stage ignition, and fairing separation. Electron's second stage is now on its way to orbit. We'll listen in for the call that Electron is orbital at approximately 9 minutes into flight.
Altitude is 150 kilometers.
Our next milestone will be battery hot swap. One of the unique features of Electron is that our Rutherford engine uses electric pumps. These pumps are powered by batteries, but once these batteries run flat, they're just dead weight. To overcome this, we perform a hot swap, where we switch from 2 depleted batteries to a third fully charged one. We then jettison the depleted batteries, and that mass savings allows a more efficient ride to orbit. Battery jettison occurring at around T plus 7 minutes.
4 kilometers per second.
Coming up on hot swapping. Eject.
Stage 2 propulsion nominal.
We've had successful hot swap of our batteries, and Electron is performing nominally.
5 kilometers
Just to
per second.
recap, we had successful ignition, Stage 1 burn, and stage separation, and now we're following Stage 2 as it continues to orbit. This burn will continue until around T plus 9 minutes, and then our kick stage will separate.
Copy after you saved.
30 seconds remaining.
We have about 30 seconds remaining in the Stage 2 burn. Electron is following a good trajectory, and propulsion is nominal.
10 seconds.
Vehicle is orbital.
Stage 2 engine shutdown.
Shutdown. Transfer orbit appears nominal.
Staging.
That call confirms Stage 2 engine shutdown and kick stage separation. The kick stage is now entering a coast phase for around 40 minutes before the Curie engine will ignite to circularize its orbit and deploy the payloads.
The mission, which marked the third orbital flight for the New Zealand-based spacecraft, was carrying 13 nanosatellites selected by NASA as part of the agency's Alana 19 CubeSat Launch Initiative mission. These included the Compact Radiation Belt Explorer series, which will measure high-energy particles in Earth's Van Allen radiation belts. The Advanced Electrical Bus, or ALBUS CubeSat, which is testing new solar arrays and high-capacity batteries. The CubeSail, which is deploying and testing a solar sail blade. The NMT-SAT, which is studying Earth's magnetic field and high-altitude plasma density. Then there's RSAT, which is a CubeSat equipped with robotic arms. Then there's the Ionospheric Scintillation Explorer, or ISX, which is studying plasma fluctuations in the upper atmosphere. Other CubeSat payloads are testing radiation shielding, new navigation systems, new space software systems, and there's the Da Vinci satellite, which is loaded with experiments developed by school kids. The flight was controlled from Rocket Lab's Mission Control Center in Auckland, where the company also builds its Electron launch vehicles. The Electron is a 17-metre tall two-stage carbon composite rocket designed to carry small payloads up to 225 kilograms into low Earth orbit. The first stage of the Electron is powered by 9 electric pump-fed 3D printed Rutherford rocket engines fueled by RP-1 kerosene and liquid oxygen propellant. The second stage uses a single Rutherford engine optimized for vacuum operations. This mission also included a third stage, a Curie kick motor, designed to deploy satellites into the correct orbits. With the success of its third orbital mission, Rocket Lab's manifest is now expected to see regular launches every few weeks, sparking the need for a second launch complex, which will be established at NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January, of course, is the first month of the year in both the Julian and Gregorian calendars. The name originates in the Latin word for door, because January is the door to the new year and the opening to new beginnings. Interestingly, the month is conventionally thought of as being named after Janus, the mythological Roman god of beginnings and transitions. But according to ancient Roman farmers' almanacs, it was actually Juno who was the traditional god of January, even though Juno is celebrated in June. Okay, let's start our celestial skywatch tour looking to the northeast, with the brightest star in the night sky, Sirius, the dog star. So called because it's also the brightest star in the constellation Canis Major, the big dog. The name Sirius actually means scorching or brilliant, a clear reference to the spectacular brightness of the star in the sky. As well as being one of the nearest stars to the Sun at just 8.6 light years, Sirius is also intrinsically bright, 25 times brighter than the Sun. By the way, a light year is about 10 trillion kilometres, the distance a photon can travel in an Earth year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Now, looking to the north of Sirius, but staying to the east of the constellation Orion, which dominates the sky this time of year, you'll see the bright star Procyon in the constellation Canis Minor, the little dog. Now, although it looks like a single star from our viewpoint here on Earth, it's actually a binary star system comprising a spectral type F main sequence white star, Procyon A, and a faint white dwarf companion, Procyon B. Located about 11.46 light-years away, Procyon A has about 1.5 times the mass and twice the radius of the Sun. It also has about 7 times the Sun's luminosity, making it unusually bright for a star of its type, and that suggests that it's starting to move off what we call the main sequence, where stars are fusing hydrogen and helium in their cores, and all that means it's about to expand into a subgiant as nuclear burning moves further out from the core. As it continues to expand, the star will eventually swell to between 80 and 150 times its current diameter, in the process becoming either an orange or red giant. This will probably happen sometime within the next 10 to 100 million years. The two stars, Procyon A and B, orbit each other every 40.82 Earth years at an average distance of about 15 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which is about 150 million kilometres, or 8.3 light minutes. Okay, let's look due north now, just above the horizon this time of year, and you'll find the bright yellowish star Capella. Located some 42.9 light-years away, Capella is the brightest star in the constellation Auriga, the Charioteer. Capella is the Latin name for a small female goat. The star's alternative name is Capra, which was more commonly used during classical times. Although it appears as a single star to the unaided eye, Capella or Capra is actually a system of 4 stars in 2 binary pairs. The first pair comprises 2 bright yellow giants, both of which are around 2.5 times the mass of the Sun. Having exhausted their core hydrogen fuel supplies, both stars have now cooled and expanded to become giants, moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, just 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of the Sun. Known as an aging red clump star, Capella AA is fusing helium into carbon and oxygen in its core. As for Capella AB, well, it's a slightly smaller and hotter subgiant, with about 73 times the luminosity and almost 9 times the radius of our Sun. It's now in the process of expanding to become a red giant. The Capella system is one of the brightest sources of X-rays in the sky, thought to come primarily off the corona of the more massive giant. The second pair of stars in Capella are located about 10,000 astronomical units away from the first pair. They consist of 2 faint, small and relatively cool spectral type M main sequence red dwarf stars. They've been designated Capella H and Capella L. Almost directly overhead this time of year, in a celestial position known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. Canopus is located some 310 light-years away in the constellation Carina the Keel. Canopus is a core helium-burning giant no longer on the main sequence. It has about 8 times the mass, 71 times the radius, and some 10,000 times the luminosity of our Sun. Canopus is also a bright source of X-rays, which are probably produced by its corona, magnetically heated to several million Kelvin. The temperature's likely been stimulated by fast rotation combined with strong convection percolating up through the star's outer layers. No star closer than Canopus to our solar system is more luminous than it. In fact, it's been the brightest star in Earth's night sky during 3 separate epochs over the past 4 million years. Other stars appear brighter only during relatively temporary periods, during which they're passing the solar system at much closer distance than Canopus. In fact, it was only about 90,000 years ago that Sirius moved close enough to overtake Canopus to become the brightest star in our night sky, a place it'll retain for another 210,000 years. But in some 480,000 years from now, Canopus will once again be the brightest star in our night skies, and it will remain so for a period of at least 510,000 years. As for the name Canopus, well, it's generally considered to originate from the mythical Canopus, who was the navigator for Menelaus, the king of Sparta. Canopus forms part of the stellar association or astrum known as the False Cross, which straddles the constellation Carina the Keel and Vela the Sails, and is often confused with the real Southern Cross or Crux. January plays host to one primary meteor shower, the Quadrant Heads. Most meteor showers radiate out from recognizable constellations like Leo's Leonids, Gemini's Geminids, and Orion's Orionids. But the Quadrantids are meteors that appear to radiate out from the location of the former Quadrans Marelis constellation. You see, in the early 1920s, the International Astronomical Union divided the sky into 88 official constellations. However, that meant more than 30 other historical constellations didn't make the cut. The Quadrans Marelis area of the sky is within the boundaries of the official constellation Bootes. The radiant point for this shower is near the Big Dipper, between the end of the handle and the quadrilateral stars marking the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers, with up to 80 meteors an hour. They're best seen from the northern hemisphere, but unlike other meteor showers which tend to peak for a night or two, the Quadrantids only peak for a couple of hours. Also, while most meteor showers are produced by the Earth passing through the debris trails left behind by comets, the Quadrantids are one of just 2 meteor showers produced by asteroids. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus which fragmented and broke apart centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit which extends out beyond Jupiter. The progenitor is thought to have been the comet C1490Y1, which was observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was discovered by a Near-Earth Asteroid Telescopic Survey in 2003. By the way, the only other meteor shower associated with an asteroid is the Geminids, which occurred last month in December, and which are caused by debris from the asteroid 3200 Phaeton, which is also thought to be the remains of a comet. Joining us now for the rest of our tour of the January night skies is Jonathan Nally, the editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, we'll begin as always with our night sky stuff with the evening sky, which is when most people are out having a look. And the first constellation we'll go for, as usual, is the Southern Cross, because it's the one everyone wants to see, of course. At the moment, this time of the year, in the sort of mid-evening, it's still more or less upside down, low down in the south. In fact, If you're, sort of more north than the latitude of Sydney or any equivalent latitude in other countries in the southern hemisphere, Southern Cross probably, you won't be able to see it mid-evening, low down in the south, because it'll probably be hidden by buildings or trees or hills or things. But if you leave it a little bit longer in the night, the Earth will have turned a bit and the Southern Cross will sort of pop its head up above the horizon in the south-southeast, and it'll be lying on its left-hand side. And the Southern Cross, remember, doesn't look like a plus symbol. It doesn't mean a cross like that. It means like a crucifix or a kite shape. So you imagine a kite-shaped group of stars, and it'll be lying on its side, sort of left-hand side, and this far south-southeast. So have a look for that. Everyone loves the Southern Cross. It's a really amazing constellation. It's the smallest constellation in the sky, yet it has some of the brightest stars in the sky, and it really stands out once you spot it. So the Milky Way, which is our galaxy seen from the inside, is stretching right across the sky at the moment from south to north, and its star fields contain some really great constellations and deep sky objects, as astronomers call them. Starting in the south, we start at the Southern Cross, which is in the Milky Way, and then next to it is the constellation Carina, and then you get the constellation Vela, then Puppis, then Canis Major, and we end up all the way in the north with the constellations Orion, Gemini, and Taurus, which are really great constellations to have a look at. There's all sorts of star clusters and nebulae and things in there that you can see just with a pair of binoculars. If you've got a pair of binoculars, have a scan around that part of the sky. Lots of great stuff to see. And of course, for us down here in the southern hemisphere, it's the best time of year because we've got these magnificent constellations up there, and it's summertime. So it's easy to go out and have a look, because you don't have to rug up so much as you do during winter. So more or less directly north at this time of the year is a tiny clump of stars near Taurus, and it's called the Pleiades, or the Seven Sisters. Now, we've spoken about this star cluster before. It's a group of around 1,000 stars, quite a long way from Earth, but to the naked eye, under dark skies, you can see about 6 or 7 of them, and that's why they call it the Seven Sisters. Some people have claimed to be able to see 10 or 11, people with really good eyesight. If you have a pair of binoculars, get it onto the Pleiades star cluster, because you will see more than 6 or 7 stars. And it's important also, I might add, that when you're looking through binoculars or a telescope, make sure your eyes are adjusted to the night sky. Don't go out sort of straight from inside with all the lights on, out into the backyard, and then expect to see lots of stuff, even through a telescope or binoculars, because your eyes would be accustomed to the light. You've got to get yourself dark adapted. So give yourself 20 minutes or so of just staring around in the dark sky. Don't stand under a street light or something like that.
And don't use your cell phone either, because the same problem, the cell phone light's too bright.
Too bright. Ordinary torches or flashlights with white light. Try and get away from as much source of light as you can. If you do need to have a light to see by so you can see where you're going, try and get a red light, something that's got red colour instead, and as dim as you can possibly make it. So you can even just get an ordinary torch or flashlight and put some red cellophane over the front of it, a few layers of it. It's not the best, but it's good enough. Protect your night vision, and that means you'll be able to see a lot more. Turning to the planets, the only one visible to the naked eye in the evening at the moment is Mars, which you'll find in the northwestern part of the sky after sunset. If you're not sure which way is west, well, that's where the sun sets. So just watch where the sun goes down, and once it gets dark enough, you'll see this orangey red, medium brightness star in inverted commas, but this is the planet Mars, which of course is a planet. And if you're having trouble finding out which dot of light it is, just wait until January the 12th, because the moon will be very close to Mars on that night. So if you go out and spot the moon on January the 12th, you'll see very close to it is this orangey red star in inverted commas, which is the planet Mars. Now, if you're up early in the morning, there are a few planets to see during January. Mercury, which is the innermost planet, is very low, really low on the eastern horizon, and probably impossible to see for most people because, as I said before, you might have buildings or hills or trees and things in the way, so sort of forget Mercury for the moment. But better placed for viewing are Venus and Jupiter. Both of them are very, very bright planets. Venus is the brighter of the two, and it's higher in the sky than Jupiter. So get out about 5 o'clock or so in the morning before the sun comes up. You'll see these two bright lights out in the east. And the one up above, brighter, is Venus, and the one down below, a little bit dimmer, is Jupiter. And later in the month, as Venus and Jupiter's position changes in the sky as they're going around in their orbits and we're going around in our orbit, the sort of angles change. Later in the month, you'll see them side by side on the 22nd of January. So if you get a chance to get up early on that morning, 22nd, have a look. It should look really, really specky, these two bright lights out there in the east. And finally, the only other major planet that's visible to the naked eye, Saturn, is out of sight for most of the month, but it will pop its head up over the eastern horizon before dawn in the last week of January. So if you see a medium brightness, slightly yellowish looking star, but it's really a planet, coming up over the horizon 5 o'clock or so in the morning, the last week of January, that'll be Saturn. And it'll get higher and higher in the sky as the weeks weeks and months pass, and you'll get a much better view as things go along.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study shows plant growth has increased across the world over the last 30 years, in part because of the expansion of agriculture and also partly due to rising CO2 levels caused by the use of fossil fuels. A report in the journal Nature, Ecology and Evolution claims plant growth has increased fairly consistently between 1982 and 2011. And that around 65% of that change could be explained by three factors: expanding croplands, rising CO2 levels, and intensifying nitrogen deposition. But before getting too excited that plants may help save humanity from climate change, the researchers say the expanding agriculture is also causing a loss of soil carbon, and that is further increasing carbon emissions. In other words, it's making things worse. European researchers have reconstructed a virtual three-dimensional Neanderthal thorax based on the most complete skeleton of the hominin ever found. The findings, reported in the journal Nature Communications, suggest the thorax of Neanderthals was similar in size to that of modern humans, but it had a very different shape, making it likely that they breathed differently from Homo sapiens. Scientists found the lower section of Neanderthal's thorax was wider, meaning they could breathe more deeply and take in more air than modern humans. A new study claims the red, brown and blue-green pigments in birds' eggs first evolved when our feathered friends were still dinosaurs. A report in the journal Nature analysed fossilized eggshells from all the major dinosaur groups. Scientists found preserved pigments in spotted and speckled patterns of the shells of dinosaurs belonging to the group that includes modern birds. Meanwhile, the eggs of dinosaur groups that were less closely associated to modern birds, including Triceratops and Diplodocus, didn't contain any pigments, and so would have been rather plain. Glyphosate, the active herbicidal ingredient widely used in weed killers like Roundup, has been discovered in common brands of dog and cat foods. The Cornell University study, reported in the journal Environmental Pollution, found glyphosate present at low levels in 18 different pet foods purchased from local stores, including one brand claiming to be GMO-free. The glyphosate was found in concentrations ranging from around 80 to 2,000 micrograms per kilogram. That's considered a safe level for human consumption. One of the surprising findings of the study was that the glyphosate detected in the GMO-free product was found at higher levels than those of several other processed feeds. All this suggests that keeping feedstocks uncontaminated is a real challenge, even in a GMO-free market. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.